In this video, we are going to explore the ambiguous case. Now, you can be given different sets of information like side, angle, side, 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 angle, side, angle. But the ambiguous case is when you are given side, side, angle, two sides and the non-included angle. When you have that set of information given, you don't know if you can make a triangle out of that information at all. So when we set these up, you're going to think of it as having your angle, and then you're going to have a rigid side and a swing side. The swing side, sometimes it's too short, and it's shorter than the height of the triangle. So it won't form a triangle because it won't reach. So sometimes there will be no triangles that you can form. Other times, if the swing side is exactly the height of the triangle, then you can form one triangle, a right triangle. Other times, if the swing side is larger than the height, then you can form a triangle still out like this. Now, if the swing side is bigger than the rigid side, then that's it. You just have the one triangle. Now, compare that with one more case. If the swing side is long enough to reach, meaning it's longer than the height, but if it's shorter than the rigid side, then what happens is you could form two triangles. This 7 could be here, forming this blue triangle on the outside, or this 7 could fit inside and form another triangle. But that only works when the swing side is shorter than the rigid side. If it was longer, like here the swing side is 12, there's no way that that 12 is going to fit inside the triangle, because this is only 10. 12 would stretch outside and would not fit in here at all. It only fits outside. So you can only make one triangle when the swing side is bigger than the rigid side. So we're going to use this type of thinking and just practice determining whether or not we can form a triangle, and if so, can we form one triangle or two triangles. So as soon as you notice that we have two sides and an angle, I recommend that you set up your diagram in the following way. Go ahead and make a horizontal line like this, and then on the left side form an angle like this. This will be the angle that you're given, so I will put the 63 right here. This will now be angle C. Now, imagine that this is a hinge. Okay, so we're going to have side C that will be across from angle C. Potentially, it's going to be over here. Okay, so I'm going to put the 12 right here. Now, depending on the other lengths, actually it might not reach at all. There may be no triangle that it can form, or it could be two triangles. So we'll have to see. But for now, I'll write that there. Now, the other side, let that be the rigid side. So I'm going to put the 9 right here. That makes this side B, which makes this angle B, which means this must be angle A. Okay, now to figure out whether or not we can make a triangle out of this, we need to know the height. Okay, so consider a vertical line that we could drop. This would be the height. We can calculate this using sine. Okay, the sine of 63 would be opposite over hypotenuse, so that would be h over 9. Multiplying both sides by 9, okay, that gets h by itself. So 9 sine 63. I'm just going to put that in my calculator real quick. 9 sine 63, I'm getting 8.02. Okay, so this is 8.02 is the height. So, is the swing side long enough to reach? Yes, the swing side is longer than the height. So it will definitely form at least one triangle. So now the question is, will it be just one triangle or two? Well, that depends on whether or not we can make another triangle. Let me just move this for a moment. Can we make another triangle by letting this swing to the inside? So can I make another triangle in here, like this? And the answer is no, because this is too long. Imagine that I tried to make this be 12. Well, the rigid side is only 9. This 12 is longer than that, so that's going to stretch outside. There's no way that this is going to fit. It has to be shorter than the 9. So it will not swing inside. It won't fit inside. So that means that we can only make one triangle. Oops. I erased too much. But we already have our answer. The answer is one triangle. Okay. Now let's take a look at number 10. Again, we see that we have two sides and an angle. So again, you should draw your diagram like this. And we'll put the angle right here. There's 33, so that makes this B. We'll put our swing side over here temporarily. That makes this side B. So the 22 goes here. The other side will be the rigid side. Okay, so I'll put the 27 right there. That's A, so that means that this is angle A over there. And angle C must be the one that's left. So, first we have to see if we can make a triangle at all. And the way we will see that, again, is by imagining a vertical line. That's going to be the height. We have to figure out what the height of this triangle is going to be. So we will use the sine function. So sine of 33, that's going to be opposite over hypotenuse. So that'll be h over 27. Multiplying both sides by 27 gives me 27 sine 33 is equal to that height. So I'm just going to put this in my calculator right now. 27 sine 33. I'm getting 14.705. Okay, so this is approximately 14. So will this make a triangle? Yes, it will make at least one triangle. The 22 is long enough to reach because it's longer than the height. So we will have at least one triangle, but perhaps we can form two triangles. So to decide if we can form two triangles, we have to ask ourselves, could the swing side fit on the inside? Could it swing to this position and fit? So imagine that the 22 were right here. Would that fit? Yes, it would, because the rigid side, the side that doesn't move, is 27. That's bigger than 22. So 22 would fit inside of here. So we could make a triangle two ways, either on the outside or the inside. So we can have two triangles. So that's going to be the answer to number 10. Two triangles. Okay, let's keep practicing. Number 11. We're just going to do the same thing again. Okay, we have two sides and an angle. As soon as we see that, we're going to draw a horizontal line. We're going to put an angle in there, and we're going to imagine this is a hinge, and we will temporarily draw our swing side. So our one angle is this 29 degrees, and that's angle B, which means this is side B, so that means the 19 goes here. The other side needs to be the rigid side, the side that doesn't move. That's what rigid means. And so this is side A, which makes this angle A, which means this must be angle C. So first we have to decide, can we form a triangle at all? And we can tell that by calculating the height. So this is the height. We can find this using sine. So sine of 29 is opposite over hypotenuse, so that'll be h over 14. Multiplying both sides by 14 is going to give me 14 sine 29 is equal to the height. I'm just going to punch it in my calculator. 14 sine 29. Okay, that is giving me 6.787. Okay, so that is approximately 6.8. So I'm just going to put 6.8 for a moment. So, is the swing side long enough to reach and form a triangle? Yes. 19 is longer than 6.8. So it's definitely long enough to reach. So we will at least have one triangle. So the question is, will we have one triangle or will we have two triangles? Well, to figure out if we'll have two triangles, we have to ask ourselves, could it also fit, could the swing side swing inside and fit? Can we do this? The answer is no. Imagine that we put the 19 here. This would not fit. Look, the rigid side is 14. 19 is longer than 14. So there's no way it's going to fit on the inside. So that's a no. So we're only going to have one triangle, and that's with the swing side on the outside, like this. So the answer, number 11, is one triangle. Okay, similarly, number 12. We have a side, and an angle. So as soon as we see that, we draw this picture. Okay, we put our angle here. So this will be the 95 degrees. This is angle B. That means this must be side B, so the 24 goes here. The other side will be our rigid side. So this 5 must go here. That's side A, which makes this angle A, which makes this angle C. We have to ask ourselves, will this make a triangle at all? To see if this swing side will reach, we need to calculate the height by finding the sine of this angle. So the sine of 95 will equal opposite, sorry, shouldn't be pointing at that. Sine of 95 is opposite over hypotenuse. So that's h over 5. Multiplying both sides by 5 gives me 5 sine 95 is equal to the height. I'm just going to plug that in my calculator real quick. 5 sine 95. I'm getting 4.98. That's the height. Okay, so obviously the swing side is plenty long enough to reach. It's far longer than the 4.98. So it will reach and form a triangle. The question is, will it form two triangles or just the one? Well, the only way it's going to form two triangles is if we can also take this side and swing it inside, like this. Can it be in both places? And the answer is no. 24 is not going to fit here, because the rigid side is only 5. It's very short. 24 is going to stretch way out of here. So that's a no. There's no way 24 is going to fit inside this 5. So again, we're only going to have one triangle, the outer triangle. 1. Okay, let's keep going. Let's look at number 13. So we have a side, and an angle. So as soon as we see that, we're going to worry about the ambiguous case, and we're going to draw our diagram like this. Okay, that's the swing side. The angle will go right here, 29. Now this is angle A, which means this is side A, so that's why the 17 goes here. The other side has to be the rigid side. So the 18 goes here on the rigid side. So if this is C, that makes this angle C, which makes this angle B. That's left. Now, we have to ask ourselves, will this swing side actually reach and form a triangle at all? To know that, we need to know the height of the triangle. So if this is the height, we can find it using sine. The sine of 29 is opposite over hypotenuse, so that's h over 18. If I multiply both sides by 18, I get 18 sine 29 is equal to that height. I'm going to put this in my calculator real quick. 18 sine 29. I am getting 8.727. Okay, so 8.7-ish. So will the swing side reach? Sure, 17 is plenty long enough to reach if the height is only 8.7. This is longer than 8.7, so it will reach. That means we will have at least one triangle. The question is, will we have two triangles? Well, the only way we could have two triangles is if the swing side can swing inside like this. So if the swing side is 17, imagine that we put the 17 here. Will 17 fit inside of here? Yes, it will fit, because the rigid side is 18. That's longer than 17. So 17 will fit underneath the 18. So 17 could form a triangle out here. The swing side can form a triangle out here. And the swing side can also form a triangle this way, okay, on the inside. So that's two triangles. Okay, let's analyze one more. I think this is the last one. Let me just take a quick scroll down. Nope, this is it. This is the last one. So one more time. We have two sides and an angle. As soon as we see that that's the case, we're going to draw a diagram similar to this one. Okay, we're going to go ahead and draw a triangle similar to this. I've made this dotted because that's my swing side. It's ambiguous what's going to happen there. We'll put the angle that we're given right here, 35 degrees. This is angle B, so that means across from it must be side B, so that's why I'm going to put the 6 here. The other side we're given, we're going to let that always be the rigid side, the non-moving side, so I'm going to put the 24 right here. If this is side A, that means this is angle A. That just leaves angle C. So the question is, can the swing side actually reach? Is this 6 long enough to reach from C to A and form a triangle? The only way we can know that for sure is by calculating the height of the triangle. Alright, we can do that very easily using sine. So if we think about the sine of 35 degrees, sine is opposite over hypotenuse, so that'll be h over 24. Now, if I multiply both sides by 24, I'm going to get 24 sine 35 is equal to that height. Now I'm going to punch this into my calculator real quick. 24 sine 35, and so that's giving me 13.766 for my height. Okay, so this is 13, I'm going to round this to 13.8 for right now. Okay, so the height is approximately 13.8. Is this swing side long enough to reach? And we see that the answer is no. The swing side is not long enough to reach. The swing side is only a length of 6, while the height is 13.8. So there's no way this tiny little 6 is going to reach all the way and form a triangle. Even if we put it straight down, alright, which will come the closest, 6 is less than half of this. So if I try to stretch this 6 down, it's only going to go less than halfway down, and it will not reach the ground. It will not reach the other side. So it cannot form a triangle. So the answer to number 14 is none. 0 triangles can be formed. Alright, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.